Chemistry is a branch of science which deals up with the atoms, ions, molecules of any matter. Inorganic compounds are the compounds which does not consist the carbon and hydrogen atoms in it. Matter can exist in three physical states, that is solid, liquid and gas. The elements combine chemically to form the compound. That's why it can easily separable. Hello everyone, this is Harshita Bhavasar from Vidhyaashram School of Excellence. Today we shall start up a new chapter, that is some basic concepts of chemistry. In that we are starting up a new session. We'll see the first exam corner or the weightage of marks allotted for this chapter. Periods whatever we have to take is 18 and the marks allotted for this is 7 marks. And the content what we are discussing today is introduction of chemistry, importance and scope of chemistry, what is matter, pure substances, mixture and units of measurement. These are the contents we shall explain or I shall explain in this session. So, first, what is chemistry and what are the importance of chemistry and what are the branches involved in chemistry, we will look. Okay, chemistry is a branch of science which deals with the study of matter. It's unique branch of science. It accounts for the physical and chemical properties of all substances in terms of well-defined structures of the constituent particles like atoms, molecules and ions. We know chemistry is a branch of science which deals up with the atoms, ions, molecules of any matter. If we take any matter in the nature, we shall explain what are the physical properties. First we will see and what are the chemical properties. So both the properties will be studied under the subject chemistry only. Okay. And it has to deal with the study of changes in various physical quantities that occur during both physical and chemical changes. Whatever the study of nature or study of matter we are looking up, it has to deal with the study of changes. Okay, there are so many kinds of changes we will observe during the processes going to happen, that is physical and chemical changes will be happening. Therefore, measurements of physical quantities with suitable units, ratios of physical quantities between the reactant and product which are involved in the chemical reactions discussed in this unit. Whatever the physical changes and the chemical changes are going to happen, it will be seen in the section of physical quantities or we will study in the physical quantities unit. For each physical quantity there is a unit will be involved. Okay, for temperature Kelvin, like that any kind of physical quantity there is a unit for that physical quantity. Okay, what they are telling means, therefore the measurement of physical quantities with suitable units or ratios of physical quantities between the reactants or reactant and the product, and that will result in the chemical reaction. First the reactant, between the reactants only the reactions will happen, and after that reactions and reactant and the product will happen. That will understand here under the chemical reaction in this unit. What are the branches of chemistry and why we will study the branches of chemistry means, there are various kinds of branches in the chemistry, that is physical, analytical, physical, inorganic, organic and computational, biochemistry and analytical. There are various kinds of branches in chemistry, but as per our syllabus we will study only 3 branches, that is physical chemistry and inorganic chemistry and organic chemistry. Okay. Then what is physical chemistry? Physical chemistry is the branch of chemistry deals with the study of behavior of matter at an atomic or molecular level. Physical chemistry is also a branch of chemistry. It study about the behavior of matter from the atomic level to a molecular level. Any constraint of the physical quantity will be discussed in the physical chemistry branch. And inorganic chemistry is also a branch of chemistry which deals with the study of compound which does not consist carbon and hydrogen atoms in it. What are inorganic compounds or inorganic chemistry? Inorganic chemistry is the study of inorganic compounds. Then what are inorganic compounds? Inorganic compounds are the compounds which does not consist the carbon and hydrogen atoms in it. And what is organic chemistry? It is also a branch of chemistry which will study the properties of organic compounds. Then what are organic compounds? Organic compounds are the compounds in which it involves the scientific study of organic compounds. What are those means? Organic compounds is nothing but the compounds which are having only carbon and hydrogen as a major elements. There are minor elements also like nitrogen, oxygen, phosphorus, sulfur, like that. But the major one is carbon, hydrogen and oxygen. Okay. And we will call chemistry as a general science because it involves a biological part and chemical and also physics, everything, and mathematics also we will include to understand the problems. For that reason itself, we will tell chemistry as a general subject or a general science. Next is importance and scope of chemistry. In our daily life, chemistry is playing a very vital role by its contributions. What are those contributions? In our life, it is contributing means it is providing food, clothing and shelter. In the manufacturing of fertilizers, pesticides and preservatives. We know what are fertilizers, pesticides and the preservatives. What are fertilizers? It will enhance the fertility of the soil. And what are pesticides? It will kill the pest or insects which will harm for the crop. And what are preservatives? Whatever food if you want to keep in a good condition without spoiling, you need to add the preservative in that food. All are come from the chemical industries. Okay, by that, in the food manufacturing, it will help in the various functioning. Both natural and artificial fibers that are used in producing cloths, all dyes which are used to color the cloths are chemical substances. Whatever fibers, which it may be a natural fiber or the artificial fiber, which will use it to produce cloth are from chemistry, and also whatever the coloring substance it will be present on the cloth are a colored substance. Okay. How the color will be produced? By the chemical substances only. Basic materials like cement, sand, steel, etc. that are used to build houses, roads, bridges and dams, etc. are all chemicals. Whatever you need, food means these three are needed. You need cloth means dyes and the fibers are needed. And if you want the shelter means you need cement, sand, steel, iron, any kind of alloys with respect to shelter is all will come from the chemicals only. And next, in providing good health. You know that nowadays the medical field is playing a very important role in our life. How it is important? Because we have seen so many pandemic situations. In that time, only we got that result from the medical field. How it is doing means different types of drugs for ailments are chemicals. Whatever, if you get the pain or if you get some infections, those will be cured by only drugs. How the drugs will come into the existence? It will be done by the molecular rearrangement for the particular disease or the particular infections. By thus, you will get the good health. And various kinds of diseases was not having a prevention or not having a treatment before, but nowadays it is having so many therapies and also so many medicines. Like that, compounds such as cisplatin and Taxol that are used to cure cancer and drugs like azithromycin that is used to control AIDS. Before, for cancer and AIDS, there was no treatment at all, but now to prevent something or to cure, there is a medicine called cisplatin and taxol to cure cancer and azithromycin to cure AIDS, to control AIDS, or have been invented. Next is in industries. Physico-chemical principles are applied in industries to produce useful materials that are required in large scale or economically. We know that for any nation, industries are only a backbone, one side, another backbone to grow economical way. For that, small scale industries will help up the large scale industries. From the large scale industries only, the nation's economy will build. In the production of soaps, alkalis, acids, salts, metals, alloys, etc., it also helps. In industries, whatever the pharmaceutical, whatever the cosmetics you people are using, those things also will come from some kind of chemicals. And the cleansing agents like acids and all also are all chemicals. Metals and alloys are also come from chemical industry only. And we will tell from the chemicals only the pollution will start, right? But there are so many principles are used to control pollution. What are those? Chemistry has provided the large number of methods to control air, water and soil pollutions, either by removing pollutants effectively or by providing safer materials in place of banned dangerous materials. Some chemicals will be having the affinity with the pollutants. By that affinity only, it will take up the pollutants from the air, water and soil. Like that, it will help, or else the industries are giving the eco-friendly products for the usage of human beings to control the pollution. Okay. And see here, what are the scope or importance of chemistry? You can see in this picture. Whatever we have discussed now, see here cooking and also batteries also, lithium battery you have seen, that is also a element. And food, paper industries also, pills is nothing but medicine, soap, petrol, concrete is cement, plastic, cloths, crackers, papers, but it will create some pollution. Everything is come from chemistry. That's why we'll call it as chemistry as a general science and very important to our daily life. Next we'll see matter. Anything which has mass and occupies space called matter. See here, has mass and occupies space is called matter. Anything with whatever you will see, that all things belongs to matter, but in a different states of matter. Okay. See, for example, pen, books, water, air, etc. All are matter, it is having some mass and occupies space, but all are in different conditions, that is, it will differ in states of matter. First we will see how the matters will be classified. The matter will be classified in physical classification and also chemical classification. First we will see what based on physical classification, how the matter has been divided. Matter can exist in three physical states, that is solid, liquid and gas. How they have been differentiated? That is by the freedom of movement. By the freedom of movement, matter can exist in three different ways. Solid. First we will see the solid. These particles are held very close to each other in an orderly fashion and there is not much freedom of movement in the molecules. Solids have definite volume and definite shape. The general characteristics of solid, liquid, gases we are seeing from our lower classes. But once again we are discussing in this unit that solids have definite shape, definite volume and it is having a proper pattern. How the proper pattern has been made? Because of there is no much freedom of movements in it. Okay. And the particles are very tight in the substance. And liquids, the particles are close to each other but they can move around in. Liquids have definite volume but not the definite shape. They will take the shape of container which is it has been placed. In liquids also, movements of particles are good, but it is not much free as gas, not much tight as solid. It doesn't have shape, but it has volume. How it will occur the shape means wherever you will place the liquid, that container shape will produce its own. Next is gases. The particles are freely arranged and their movement is easy and fast. Gases have neither definite volume nor definite shape. They completely occupy the container in which they are placed. We know gases are freely and fast. Also, it is easy in their freedom of movement and it doesn't have volume as well as shape. They completely occupy the shape of the container where it has been placed. This is about the physical classification of matter, about solid, liquid and gases. How it has been interconvertible based on temperature and pressure, we will see here. Okay, these three states of matter are interconvertible by changing the conditions of temperature and pressure. Okay, on heating a solid usually changes to a liquid and the liquid on further heating changes to gaseous state. In the reverse process, a gas on cooling liquefies into liquid and liquid on further cooling freezes to solid. See here, this is solid, molecules in fixed pattern. After getting melting, it forms liquid. After getting more heat, it will start vaporizing or evaporating and gases move widely separated. In the vice versa, on the condensing it will form liquid, on freezing it will form solid. Okay, the best example is water. If it is in a solid state means it is ice. On heating it will form liquid. On again heating it will form a gaseous steam. It can again interconvertible also. Okay, and the classification of chemicals based on chemical composition. We have seen the physical classification of matter. Now we are seeing the based on chemical composition. Matter is divided into pure substance and mixture. Okay, what is pure substance? Only one kind of elements or molecules will be present in the pure substance, that is fixed composition and properties. Okay. Again, pure substance will be divided into elements and the compounds. Elements cannot be decomposed, but compounds can be decomposed by chemical reaction. And the elements combine chemically to form the compound. That's why it can easily separable. And the compounds chemically separable into elements. Okay. That is how the pure substance has been divided into elements and compounds. Another side, mixture. Mixture is nothing but two or more elements will be mixed to each other. How it will be? If it is in a uniform way, that combination will called homogeneous mixture. If it is a randomly mixed, that will call it as heterogeneous, that is non-uniform mixture. Heterogeneous can be physically separable into a homogeneous. This is about the chemical classification of matter. We will see one by one now. What is pure substance? A pure substance is a single substance which cannot be separated by simple physical methods. Okay, it is already one single substance. It cannot be separated again by a simple physical methods or actions. In NEET classification, an element consists of only one type of particle. See here, hydrogen, oxygen, nitrogen, copper, sodium. In this element, the atoms will be presenting, all the atoms are whatever it is present in each element are identical atoms. If it is hydrogen element, all the atoms are hydrogen atoms only. If it is oxygen element, all the atoms are oxygen atoms only. That is nothing but element. This may be atoms or molecules. that is sodium, copper, water, oxygen, nitrogen molecule. See here, an atom of hydrogen plus another atom of hydrogen will form a molecule of hydrogen. Okay. See here, compounds. It is containing two or more elements combining together in a fixed proportion by weight and can be decomposed into these elements by suitable chemical methods. Any compound by two or more elements, it will be in a fixed proportion by weight and can be decomposed into the element by suitable chemical methods. You take as a water molecule only, here 2:1, right? It is a fixed proportion. That's why we'll call it as compound. Next is mixture. Mixtures are either homogeneous or heterogeneous forms of matter and composed of variable proportion. Example, sugar solution in water, soil, ocean water, air, etc. There are two types of mixture, that is homogeneous mixture and heterogeneous mixture. As I already told, homogeneous mixture means mixture of two or more pure substances forming a single phase and having a uniform composition throughout is called homogeneous. Homo is nothing but uniform. Okay, that mixture will call it as a homogeneous mixture. Example, sugar solution in water and air, etc. Heterogeneous means mixture of two or more pure substances forming many phases and does not have the uniform composition throughout is called heterogeneous mixture. Mixture of salt and sugar, grains and pulses, etc. Heterogeneous mixture means mixture of two or more pure substances forming many phases, not only a single phase like homogeneous, it will form many phases and does not have uniform composition throughout it. If you take salt one side, sugar one side, if you mix, how it will be randomly mixed, that we'll call it as heterogeneous mixtures. And there are other examples also, you may observe in your daily life it's only. See here, homogeneous mixture. Like this, homogeneous means uniformly arranged. If it is a plus or minus, everything it is uniformity in a single phase. In a heterogeneous, see here one color, here randomly another, and again here. It is non-uniform distribution of particles. Here, see here, like this only it can arrange as a uniform way of particles. Example, air, steel, rain and wine. And here heterogeneous means, see here, ice water, cereals in milk, soil, oil and vinegar, everything whatever here you are seeing, all are randomly mixed without the fixed proportion or no uniformity throughout. Here air means some proportion will be there. Steel, if you want to prepare, if you want to manufacture the steel in the industries, they are having the fixed proportion of making alloying. Everything is uniformity in its distribution. Okay. Next is properties of mixture. The composition of a mixture is variable. Each of its components retains its characteristic properties and its components are easily separated. Mixture is a heterogeneous form of matter. Whatever the composition of a mixture is variable. You know that if you want to compose something, it will be varied in its components. Each of the components retains its characteristic property. Whatever the components you are using to prepare a mixture, its characteristic property will retain throughout the end. And its components easily separated. Whatever you are preparing, okay, that will be easily separable. Mixture is heterogeneous form of matter. Mixture is nothing but a heterogeneous form of matter. These are the properties of mixture. And differences between the mixture and compounds. What are the differences? The compounds is nothing but two or more elements are combined chemically. Okay. The elements present in here In the compound, 2 or more elements are combined chemically, but in the mixture, 2 or more elements or compounds are simply mixed, not chemically combined. If you take the sugar and salt, there is no chemical reaction in it. You will take one side salt, one side sugar, you will simply make it in a mixture. But as a compound, if you want to prepare like NaCl or KCl, anything, if you want to prepare means you need a fixed proportion, and also you need to have a chemical reactions over it. And the elements present in the fixed ratio by mass. Here the elements will be present in the fixed ratio. Here the constituents are not present in a fixed ratio, it can vary. The compounds are always homogeneous. It may be homogeneous and heterogeneous. You know now what is homogeneous, what are heterogeneous. The compound constituents lose their identity, but here it will not lose the identity. We have seen already the properties of matter, whatever the components we are using to prepare the mixture, its characteristic property will retain. So, it will not lose its identity, but in the compound, if you making a chemical process, automatically the elemental property will not retain because it has been under the reaction. The constituents cannot be separated by a physical means because it's already chemically related. We know physical changes can be little bit reversible, but chemical changes cannot be reversible. The constituents from the mixture can be easily separated by physical means. That is also little bit difficult, but if you give us some time, it can be reversible. In the formation of a compound, energy in the form of heat, light is either absorbed or evolved. It's a chemical reaction. Here heat can be released or absorbed. Okay. No energy change is noticed in the formation of a mixture. Because we are physically doing this thing, so there is no energy change will be involved in preparing of mixture. But compound, it may be endothermic or it may be exothermic. Heat is involved, or there will be presence of heat will be released also. These are the differences between the compounds and the mixtures. See here, oxygen with the fixed proportion of hydrogen. This is ammonia or NH4 ammonium. This is also having a fixed proportion. Carbon dioxide, this air is in a fixed proportion, and this is mixture. It can be a homogeneous or heterogeneous like this. And next is properties of matter. If you want to understand the properties of matter, you first understand that is what are physical properties and chemical properties. What are physical properties? Properties of a substance which can be observed or measured without changing the identity or composition of the substances are called physical properties. Okay. These are also a property of a substance which can be observed or measured without changing the identity of without changing the composition of the substance is called physical property. Example, color, odor, melting point, boiling point, etc. If you see the chemical properties, these are also a type of property of a substance which can be observed or measured only on allowing the substances to undergo change in its identity, and composition are called chemical properties. Here if you want to know the chemical property, there what it has been done, whatever the compound or the substance, it should undergo the chemical process. That time only you can understand the chemical property. That time what will happen, it will lose its identity and composition will be changed. After changing only you will understand. Chemical properties are the characteristic chemical reactions of different substances. Okay, example here, acidic, basic, oxidative and reductive, etc. reactions. See, properties of matter. If you want to observe the color or length, volume, opacity, everything can be measured or observed without changing the composition or its identity. If you want to See the chemical properties, acidity, here also chemical reaction has been done, reactivity, flammability and toxicity. There is a chances of getting hazardous also in doing the chemical reactions also. Next is units of measurement. As I already told, if you want to measure the physical quantities or if you want to understand the physical quantities, you need some units. Without the units, whatever the physical quantities, that are all useless. So, the unit system has been called, that is system of international units, that is nothing but SI units. It is called the International System of Units or SI units. SI stands for System International des Units in French. There it has been first proposed. This was recommended by the International Organization for Standardization and the International Union of Pure and Applied Chemistry, that is IUPAC or ISO. These are two organizations, are well-known organization, and they have recommended for the SI unit system. And these are the base physical quantities and their units. What are the base physical quantities? That is length, mass, time, electrical current, thermodynamic temperature, amount of substance and luminous intensity. Whatever you want to see the physical quantities, these are the basic physical quantities. It will be having its symbol and name of SI unit and symbol for that SI unit. Okay. For length, symbol is L, SI unit is meter. For that SI unit, again small m is symbol. For mass, m, and kilogram, that is kg. Time, t, second, small s. Current, I, it will be represented by ampere, that is big A. Temperature, big T. Kelvin, K. See here, if you want to observe that small t means time, big letter T means temperature. You should not get confused. Amount of substances means N, that is mole, MOL. Luminous intensity, LV. Here also see that this is only L, this is I, this is luminous intensity will be candela, CD. These 1, 2, 3, 4, 5, 6, 7. 7 are basic physical quantities. You should remember with respect to chemistry also and physics also. That's why it is very much basic, and also you should remember its SI unit with its symbol. And prefixes used in the SI unit. See here, if you have 10 to the power of minus 24, it is yocto, Y, minus 21 zepto, 18 atto, 15 femto, like that. After minus, you will get 10, that is deca, 2 hecto, 3 kilo, 6 mega, like this. If you want to write micrometer, means 10 to the power of minus 6. That is the value of micro. If you want to write millimeter, 10 to the power of minus 3. See here, the table itself will show. Like this you have to understand. If you want to write giga, that is 10 to the power of 12. There is no negative sign. You should be remembering with the negative sign what is the term, with the positive sign what is the term. Little bit changes will be present, and these are the symbols for the prefix of that multiple. And in the next session, we will study about mass and weight, volume and density, temperature, scientific notation, and precision versus accuracy. I hope you have understood what I have taught today. We'll see you in the next class. Thank you so much.